Okay, moving on. So we are again on lesson 9 and we're doing multiple representations of a function. So far we've covered the model and the algebraic rule, and now I'm going to show you how to take that algebraic rule and put it into a table. So we've got the algebraic rule written down here already, which we just figured out to be the number of tiles is equal to 4 times the side length plus 4. And it took us quite a while to arrive at that, but we're there now. So now what we can do is we can take this formula and we can substitute in the values that are listed in the table, which we actually have already done above, but we're going to use it to mathematically figure out how many tiles that would be equal to. So if we have a table side length of 1, we would substitute 1 for that s. So we would do 4 times 1, which is 4, and then add to that the 4 corner tiles. So 4 plus 4 would be 8. And I'm going to erase all of that so I can reuse it. So the number of tiles we need for a pool with a side length of 1 would be 8 tiles. Next, we're going to determine for a side length of 2. Again, the side length we're just going to take and we're going to substitute it right in here for this s. So when s is equal to 2, what is the t equal to? So if we put 2 in for s, we've got 4 times 2, which is 8, and then 8 plus 4 is equal to 12. So I will put in 12 here. Moving on to 3. So put a 3 in for s. 4 times 3, that's 12 plus 4 would be 16. If we were to move on and do 4, 4 times 4 is 16. Add 4 to 16, you get 20. How about for 5? 4 times 5 is 20. 20 plus 4 is 24. And then for 6, 4 times 6 is 24, plus 4 is 28. So we just use this algebraic rule to turn, or to fill in a table, we turned it into a table. So we just took t, and that's listed as our y variable kind of over here. And then we've got our s, which is our side length, and that is plugged in over here as kind of our x variable. And what's nice is that this now creates points on a graph. So if we were to take this 1, 8, s comma t, hold on, I'm going to clean this up. As I was saying, I'm going to call this s comma t. Oops, I don't want eraser. I need my drawing tool. So if I had a side length, remember we said of 1, that gives me a coordinate of 1 comma 8. If we had a side length of 2, we found that we needed 12 tiles, so it would be 2 comma 12. And what we can do with this data is we can actually take it and we can graph it on a coordinate plane. So I've set up this graph for you where you've got the side length in feet across the bottom, which is where we're going to put these numbers. And then our number of tiles goes up the side, so we're going to plot our number of tiles on our y-axis here. So the first coordinate I'm going to plot is going to be that 1 comma 8. So I'm going to start at my lobby, and I'm going to walk to 1 and then ride the elevator up to 8. And that's where I'm going to put my point. The next point's going to go at 2 comma 12. So I'm going to walk to 2 and then ride the elevator up to 12. And that's where my point's going to go. And I'm going to continue this pattern. I'm going to go on to 3, 16. So walk to 3, ride up to 16. Moving on to 4 comma 20. So we're going to walk to 4, ride to 20. Five comma 24. So we're going to go to 5, and then all the way up to 24 and make our dot. And finally our 6, comma 28. So I'm going to walk to 6, right all the way up to 28. And as you can see, I am creating a line. So what I'm going to do now is I'm going to, on my Kami, I'm going to go to shapes and I'm going to select the line because it'll let me insert a line. And I'm actually just going to start about right here and I'm going to connect those lines. I'm going to go back to my drawing tool now and I'm going to put in an arrow. Actually, let's do it in the same color as the line. And we can see that this is a graph of our function t equals 4s plus 4. So now we have shown you from the model to an algebraic rule to a table, and then we just did the graph together. And now we're going to go on and we're going to analyze this graph.